Bismillahirrahmanirrahim. In this video, we'll be discussing example 4.4 emitter bias network from EDC book by Mr. Bolstead. And this is on the request of a student. Simple question. Let's do it. This is the question. For the emitter bias network, we have to determine these parameters IB, IC, BC, VC. Now, what is an emitter bias? Let's just discuss briefly. Emitter bias circuit diagram is obtained by simply introducing an emitter resistor to the fixed bias. So this is the emitter resistor that has been introduced in the fixed bias circuit that we have already studied. So this is a fixed bias circuit. In the emitter, we have introduced a resistor. So the circuit becomes emitter bias. Now its utility, which circuit is used, I have discussed in my videos, and as we go along, we'll also learn more about it. So the first thing we do that when we are doing the calculating the DC parameters, we remove all the capacitors because the capacitors are primarily meant for AC. They either connect the AC or bypass the AC. So our circuit will become like this without the capacitors. And for simplification, I always prefer that the voltage is connected through a battery. This is what has been done in the book as well. So this will be the circuit that we'll be using. So the first is IB. IB is this current. The current in the base is the IB. And for that, we will follow this loop from here all the way to ground. So we'll write KVL. And if you go from here, it's minus VCC and then IBRB. Then this is plus VBE and then IERE. This is the main formula. Now I'll plug. Okay. One more thing for simplification. What we will do is we'll use this parameter. The emitter current is actually equal to beta plus 1 IB. This I hope you know by now. So we'll replace this IE by beta plus 1 IB. So replacing this and then rearranging, and from here we can find IB. So this will be the equation for IB. And now we'll plug in the values. And so the current will be 40.1 microampere. So the base current is generally very, very small. So you can see from here, there is a small current. So we have noted IB, and now the next part is we have to calculate IC. IC is the collector current. Now there is a very simple relation between IB and IC that also you have to remember, and that is IC is beta times IB. Now what is beta? Beta of the transistor is given. Here it is 50, so it use this value. 50 times IB, this current, will give IC as approximately 2.01 milliampere. Now the third part is VCE. Now what is VCE? This is collector, this is emitter. Between this, the voltage is called VCE. So we have to find this. And for that, we can take the outer loop and write KVL. So going from here, minus VCC, then ICRC, then VCE, and IERE equals 0. And here also we can approximate IE equal to IC. And just for your knowledge, I've written the values. This is IB, this is IC, and if you add, will actual IE, the summation of IB and IC, so it will be 0.0200040, but we can approximate this to be equal to IC. So that is what has been done here. So minus VCC, this remains here, VCE and IE we have replaced by IC. Now, as a student, I also had very difficulty in understanding. Sometimes they take IE as IE, sometimes they take IE is equal to IC. But both are, unless you want to go to very, very accurate calculation, which is never done, because this is design problem, and in designing there is a lot of flexibility. So it's very good assumption to use IE is equal to IC. So plugging in here, and then from this we can write VCE, and we know all the values now, VCC and IC and RCR. So VCE will be 13.97 volt. Now just a point to note that whenever we write the voltage with a single subscript like VB, VC, VE, that means these are with reference to ground, always with reference to ground. So keep this point in mind. And we have to find now VC. Now where is VC? At the collector voltage. This is VC. And as I mentioned, this is with respect to ground. So we can write the equation from here. VCC, ICRC, and then VC equal to 0. We don't have to go this way, because here it is ending VC with respect to ground. Plugging in the value here. So it will be 15.98 volt. Next is VE, the emitter voltage. Now, two ways we can calculate this VE. One is simply IERE or ICRE, when we approximate IE as IC. The other is VE, can be written as VC minus VCE. Now VC minus this VCE will give us VE. So both way you can solve it. Putting in the value, it is 2.1, 2.01. Here also, if you put the value of VC and VCE this, and VCE 13.97, so you get the same answer. And now VB, the base voltage is here. Base voltage again can be linked to the ground. So we can write that VB is equal to VBE plus IERE or plus VE. 0.7 volt. VE we have already calculated 2.1. So VB will be 2.71 volt. And finally, VBC. Now remember, whenever the voltage is written like this, that means VB, B will come first and then will come C. That means it is VB minus VC. VB minus VC. If it was written VCB, then we should have been VC minus VB. So VBC is VB minus VC. We know both the voltages. VB is this and VC is 15.1. And so the answer is minus 13.27 volt. And it is reverse bias as required. I hope you recall that for a transistor to be forward bias, VBE has to be forward bias, for a transistor to be acting as an amplifier, VBE has to be forward bias and VBC has to be reversed bias. And that is what is here. So the transistor is inactive. So I hope you have been able to follow this. Please let me know through your comments. Thank you.